Hi guys, welcome to my channel. Today I'm just gonna cut to the chase. We're gonna be doing electrostatics, the theoretical component of it, and then in my next video I'm going to cover a bit more of the questions, right? So when we speak about electrostatics, as the term says, we are talking about static electricity, right? So what is happening here is when you have two neutral objects, you can be able to charge them wherein they can have either a surplus of electrons or a deficiency of electrons. So we all know that charge cannot be created or destroyed, but only transferred from one object to the next. So now when we talk about a neutral object, I said we can have a neutral object that can either gain electrons, or lose electrons. We can charge it using triboelectric charging, which is like rubbing two objects, and then electrons can be transferred from one object to the other. So remember that protons cannot be transferred, only electrons, right? So when a charge or when an object has gained electrons, then it obtains or acquires a negative charge. And when an object has lost electrons, then it acquires a positive charge. We usually refer to spheres when we're talking about electrostatics. So this one I said has a surplus of electrons, and this one has a deficiency of electrons, right? So the electrostatic charge is measured in coulombs, and then it's usually very small. So we use micro, milli, nano, and picocoulombs, right? So these are important to remember. There's micro, there's milli, there's micro, there's nano, and there's pico, right? The milli is times 10 to the power of negative 3. This is times 10 to the power of negative 6. This one is times 10 to the power of negative 9. And this is times 10 to the power of negative 12, right? And the charge is all measured in coulombs, like I've mentioned. So since you have either gained or lost electrons, you can be able to sort of quantify how many electrons you have gained and how many electrons you have lost, right, during your charging of the neutral object. So you can use what we call the principle of quantization of charge to be able to calculate how many electrons were lost or how many electrons were gained, right? So quantization of charge is N is equal to Q over QE. Let me get another marker because this one is not very clear. So here, this is the number of electrons. This is the charge on the object, which is usually a sphere, and this is the charge on of an electron, which is a standard 1.6 times 10 to the power of negative 19 coulombs, right? So from here you can be able to get how many electrons were lost or how many electrons were gained when the object was rubbed, right? So when you use this, when you have now two different spheres, you can either have a situation where they attract each other or they can repel each other. So you can have a situation where you have a positive charge and another positive charge, or you can have a negative and a positive charge, right? Now we all know this one. We can either have what we call, let me just remove this because I don't have enough space. We can have what we call like charges, which is either 2 positive or 2 negative charges, or we can have what we call unlike charges. These are like charges, these are unlike, right? Unlike charges attract, and like charges repel. So this now introduces the concept of like electrostatic force. Because the charges, the charge spheres can either attract or repel, there can be certain force that they can be able to experience between the two, right? So if you look at the 2 charge spheres, let's say you had a positively charged sphere of, let's put it on a ceiling somewhere. Let's say you had a positively charged sphere and a negatively charged. This one had 2 nanocoulombs, and then this one had a charge of -9 nanocoulombs. And then let's say these spheres are allowed to touch. And then they are separated. Now we know that in an isolated system, charge cannot be created or destroyed. So if this sphere A, let's call it A, and B are allowed to touch, then what is going to happen is the charge is going to be shared equally between the two, right? So you can calculate a new charge that they're both going to have after sharing the charge, which is going to be equal to the sum of the 2 charges divided by 2, right? So now if you had 3, you'd have Q1 plus Q2 plus Q3 over 3. So whenever you have 2 spheres and they're allowed to touch, then the electrons are always transferred from the more negative sphere to the more positive sphere, right? Which means they're going to be transferred from B to A. That's another important thing to note. Electrons transferred from B to A, right? Even if you had a situation where both were positive, let's say you had a positive 2 nanocoulombs and a positive 9 nanocoulombs, then it means the electrons are going to be transferred from the more negative sphere, which is the plus 2 nanocoulombs, right? So what happens when these two are allowed to touch? Like I said, you can be able to quantify. So you can say Q1, let's say Q1 is 2 nanocoulombs and Q2 is -9 nanocoulombs over 2. So you get 2 minus 9, which is -7 over 2. Then your final answer there would be -3.5 nanocoulombs. So remember that charge is not a vector, it's a scalar. But however, the positive and the negative signs are just used to indicate that you have a deficiency or a surplus of electrons. That's all they're used for, right? So now you can calculate a new charge like I've done here. And further, like I said, if you have 2 spheres, you can also be able to calculate what we call the electrostatic force experienced by the 2 spheres. So let's say now spheres, you want to calculate what we call electrostatic force. We use Coulomb's law, which says that the electrostatic force between two charges is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square distance between them, right? So if you have a charge Q1, Q2, then you can get calculate the electrostatic force, which means from this equation we can get two relationships, right? The first one is that Q1 is directly proportional, or rather F is directly proportional to the product of the two charges, the magnitudes of the two charges. And we can also get that the force is inversely proportional to the square distance between them, right? So these are relationships which are nice for MCQ questions that you must be able to know and understand. From relationships, we can always be able to draw graphs where we have a dependent and an independent variable. So for this first one, for instance, you can get a graph of F, Q1, Q2. The graph is going to be a straight line from the origin, and then your gradient or your slope is going to be 1 over r squared, right? And then you can also get another graph from this relationship. So F 1 over r squared, straight line from the origin. And then what you're going to have is the slope will give you Q1 times Q2, right? And then you can have another graph of, sorry, let's redraw this one here, of F versus r squared. This graph is not going to be a straight line since they're inversely proportional. These are the three graphs that you can get, right? And what you have to know from the graphs is the slope and the area, but more specifically for this one, the slope is just more important for you to understand what kind of variables you can be able to get from your slope, and then you can use it further for calculations. Okay, that's it for today. Thank you for tuning into my YouTube channel. I hope you found the information to be useful. I'm going to do another video now with questions on electrostatic force.